class again. Today we again start a new topic of derivatives, and quietly different. If you think most of the parts will be same as previous topics, but still something new in this chapter, in this topic. Topic will be derivative of implicit function. Derivative of implicit function. Before going to main topic, first of all I want to give you idea about what do you mean by implicit function. Implicit function means that suppose that a function in which y is dependent variable, x is independent variable, means that as y is equal to x plus 1. Suppose that I have taken y is equal to x plus 1, y is equal to x square, y is equal to log xy, y is equal to sin x plus log xy log x times log y plus tan inverse x. I have taken 4 different functions. Here y is completely expressed in terms of x. Here y is also completely expressed in terms of x. Now, if you see here, in that case, you can tell me, sir, here y is not expressed completely in terms of x, because y is expressed in terms of x and y both terms. If I am trying to express completely y in terms of x by some manipulation, in that case you can tell me, sir, can I write e to the power xy is equal e to the power y is equal to e to the power y is equal to xy, e to the power y is equal to xy. Here e to the power y by y is equal to x. That means you can tell me x is equal to e to the power y by y. That means x is completely expressed in terms of y. Now see here, that means fourth function. Here y is equal to sin x plus x log y plus tan inverse x. Now there arises simple question: can you express y completely in terms of x? Can you express y completely in terms of x? No. Why? Because whenever you are trying to express y in terms of x, then you will get y is here and another y which is combined in term log, also in multiplication of x. Whenever you are trying to take in LHS towards y, with it x is also comes as a multiplication in log y. In LHS it becomes as y minus x log y, y minus x log y, and it will be sin x plus tan inverse x. Means that I want to tell you y minus x log y, which will be sin x plus tan inverse x. Now if you see here y minus x log y is equal to sin x plus tan inverse x, means that you cannot express y or x completely in terms of x or y. Means that you cannot express y in terms of x completely or x in terms of y completely. That's why you can tell me here implicit function. What do you mean by implicit function? Implicit function means that, again I want to give you some important point. I will use in definition two important terms. A definition term first will be a dependent variable. Dependent variable, about which I have already told you in your earlier class. Still I will tell you. Second will be independent variable. Independent variable. Dependent variable means what, and independent variable means what? Dependent variable means that whenever a function, a terms or as you know that y is a simple term, suppose that this is a variable, y is a variable and it is completely expressed in terms of x, and value of y depends upon x. In that case, as you know that whenever I will tell you draw the graph of y is equal to x plus 1, definitely you will take some arbitrary point value of x, and after putting the value of x in equation y is equal to x plus 1, you will get the corresponding value of y. That means y completely depends upon x. That means y is dependent variable because y depends on x. So y is dependent variable and x is independent variable. Now similarly here y is equal to x. I want to again tell you, whenever until it is not mentioned in your question y is dependent variable and x is independent variable, you can take any variable as dependent or independent. But I think up to secondary level, or if you see up to higher secondary, whenever when you will go to study about differential equation, in that class you will discuss about also again about dependent variable and independent variable. Because without the understanding of dependent and independent variable, you will not understand very well way definition of differential equation. So I am telling you again, dependent variable and about dependent variable and independent variable in higher class it is properly mentioned. Here y is dependent variable and x is independent variable. But up to class 12th or up to 12th, you can tell me generally y is always treated as dependent variable and x is independent variable. Still, if there is no mention, if there is mention, not issue to solve any problems. But if it is not mentioned, always try to understand y is a dependent variable and x is a independent variable. Now, derivative of implicit function means that whenever in dependent variable or dependent or independent variable, if you couldn't express dependent variable in completely in terms of dependent variable or independent variable completely in dependent variable, in that case you can tell me, sir, it is an implicit function. Implicit function means that either dependent variable is expressed in terms of independent variable or independent variable completely expressed in terms of dependent variable. This is the actual definition. Here you see y is completely y is equal to completely in terms of x. That means y is completely expressed in terms of x. That's why you can tell me this is not implicit function. That function which is not implicit function, which that will be explicit. Similarly, y is equal to x. Y is equal to x is the explicit function. Why? Because y is completely expressed in terms of x. Similarly, y is equal to log x y. Here x is completely expressed in terms of y. That's why you can tell me, sir, this is a explicit function. Why? Because I have not used here what is a dependent variable and independent variable. If you suppose x is a dependent variable, then you can tell me y is independent. In that case, x is completely expressed in terms of y. That's why this is a explicit function, and this function is not an explicit function because you cannot express dependent or independent variable with respect to independent or dependent variable respectively. Means that here if you are trying to express dependent variable y in terms of x, you cannot do it. Similarly, whenever you are trying to express independent variable x with in terms of y, you cannot do it. That's why it is again implicit function. Means that implicit function means that simple implicit function means that simple logic. You have to remember it whenever you are trying to expressing one variable into other variable completely. When you completely express, then you will get that function will be explicit function. And when you will not able to express in second variable completely, you will tell me, sir, that function will be implicit function. Similarly, you can take any function. There are many functions. Y is equal to 10 to the power y plus log x. Here again you cannot express. Log x plus log, you can take log x upon y. Here if you see about this function log x plus y, log x plus sin x, you can take any. Here you cannot express completely x in terms of y or y in terms of x. That's why it is an implicit function. I think you understand. Now Here we start about what main topic will be here. You have to solve derivative of an implicit function. Means that whenever you will get that function where x and y is in implicit form, in that case, how can you approach towards the finding the value of derivative of dependent variable with respect to independent variable, means that dy dx. Here, there is a simple way to find. Suppose that there is any function which is an implicit function. In that case, you have to do only one thing, only differentiate on both sides with respect to x. Suppose that I want to write fxy is equal to any function, suppose that gxy, and you have to differentiate on both sides. This is fxy, this is gxy. In that case, you want to define the value of dy dx. Simply you have to do differentiate fxy with respect to x, and again in both sides. That means also in the right side you have to differentiate with respect to x. This is usual way to find the derivative of an implicit function. Thereafter you have to, as I have discussed in earlier class, usual way you have to proceed to find, in order to finding the value of dy dx. Now I want to take some easy problem, that means some good problems which involves in this topic. First of all, you see here 21, which is very easy. Find dy dx. It tells you find dy dx if 2x square minus xy plus y square plus 3y minus 4 is equal to 0. Here, as I have taken definition of implicit function in two terms, that means in terms of x and in terms of y. But in this, if you see this equation, you have to find here dy dx. That means you have to find derivative of dependent variable with respect to independent variable. That means simply you have to find dy dx. What is the value of dy dx? Now, here you have to treat x and y both as a variable. Other than if there is any constant, you have to always, if other than if there is any terms which is involved in this equation or in any equation, then always treat that terms or that terms as a constant. Now, if you see this equation, this is the equation. Now, if you are trying to express y in terms of x, you cannot express completely in terms of xy, because y square plus 3y minus 4 is equal to 0. Whenever you are trying to write this term 2x square minus xy right side, definitely x will take with it again what? Y. In that case, again you are trying to write it left, again will come in right. That's why you cannot express y in terms of x or x in terms of y. That's why it is a implicit function. Now I am trying to find derivative, that means dy dx. You have to find dy dx. How can you solve? First of all, suppose this is your equation first. First of all, you have to suppose this is equation first. And if it is a equation first, now you have to write here differentiating on both sides with respect to x. You have to differentiate on both sides with respect to x. In that case, you have to write a derivative of 2x square with respect to x minus derivative of xy with respect to x plus derivative of y square with respect to x plus derivative of 3y with respect to x. Here I have taken 3 already out of derivative terms, and minus derivative of 4 with respect to x is equal to 0. And you can differentiate, hence derivative of 0 will be always 0, because I have already told you in this question you have to differentiate on both sides with respect to x. Now you have to find dy dx. That's why I have differentiated on both sides with respect to x. Now if you take 2 out of this derivative term, then you have to find derivative of x square with respect to x, which will be 2x. Now you have to differentiate xy with respect to x. As you know that both variable is in multiplication form. That's why here you have to apply quotient rule of derivative. That means you have to take firstly out of derivative terms y and differentiate x with respect to x. Again take addition sign and take outside x and differentiate to y with respect to x. Have you understood? Again, differentiate y, and you know that you cannot differentiate y square with respect to x directly. That's why I want to differentiate with respect to y. Firstly, again, you have to differentiate y with respect to x. As you know that you have to find dy dx. That's why don't worry by taking it. How can we find the value of dy dx? Because you have to find dy dx. So don't worry, and only simple way, as usual way, you have to proceed. That's why here you get the derivative of y square with respect to y into dy dx plus 3 times dy dx minus derivative of 4 with respect to x will be 0, and it is also 0. Now I want to take some example step. Now I want to, this is 4x, this is 4x minus y dx will be 1, and minus x dy dx plus here derivative of y square with respect to y will be 2y into dy dx plus 3 into dy dx is equal to 0. Now if you take dy dx at one place, that means if you see in this equation, this term, that means third term, fourth term, and fifth term, in all three terms dy dx are common. Dy dx are common. If in this equation all three terms are common, so I want to write firstly this part. Now I want to take dy dx common out of it. In that case, you will get here minus x plus 2y plus 3 into dy dx. I have taken common dy dx, and I want to take it in RHS. In RHS, you will get y minus 4x. So dy dx is equal to y minus 4x divided by minus x plus 2y plus 3. This is your answer of this question. You can see what are the concepts behind it. Simply, I am again telling you, simply you have to differentiate on both sides, and as usual way, you have to proceed. And one of the important point for you, whenever you get dy dx, don't worry by taking it what is this and what is the value of dy dx, because you have to find dy dx, and finally you will that means after this step you will take dy dx common out of those terms that contains dy dx, simple way, and finally you have to find by manipulation dy dx is equal to y minus 4x divided by minus x plus 2y plus 3. If you wish, you can multiply numerator and denominator by minus n. Finally, you will get its answer will be 4x minus y divided by x minus 2y minus 3. This is your correct answer. I think you understand very well. Again, I want to take a next question for you, which is your 22. See here. See, question 22. Here function is given log x square plus y square. Log x square plus y square is equal to 2 times tan inverse y upon x, and you have to show that dy dx is equal to x plus y divided by x minus y. You have to find dy dx is equal to x plus y divided by x minus y. Now, how can you solve this problem? Suppose that this is equation first, and write here differentiating on both sides with respect to x. In that case, first of all, if you wish, you can write here differentiating on both sides with respect to x. Then you will get derivative of log x square plus y square with respect to x is equal to 2 times the derivative of tan inverse y by x with respect to x. Now, this will be derivative of log x square plus y square. Firstly, with respect to which one terms? X square plus y square. Again, differentiate x square plus y square with respect to which function? With terms x. And here, first of all, you have to differentiate tan inverse y by x with respect to y by x, and again you have to differentiate y by x with respect to x. Have you understood very well? Now, derivative of, suppose this is p, in that case derivative of log p with respect to p will be 1 upon p, that means In place of p, there is given x square plus y square into derivative of x square plus y square. Derivative of x square with respect to x will be 2x, and derivative of y square with respect to x. I want to write here firstly, derivative of y square with respect to x you cannot find directly. That's why I want to solve separately. Firstly, you have to find derivative of y square with respect to y. Again, you have to find derivatives of y with respect to x. First one will be 2y times dy dx. 2y times dy dx. That means there you will take right here 2y dy dx. 2y dy dx, and which will be 2 times derivative. What is the, suppose that this is p. Derivative of tan inverse p with respect to p will be 1 upon 1 plus p square. That's why there will be 1 upon 1 plus p square, means that y square upon x square. Into derivative of y upon x with respect to x. Simply you have to go through using quotient rule. Quotient rule, that means you have to take x out and x as a out, and you have to take differentiate y with respect to x. Again minus, take out y and differentiate x with respect to x. Divided by denominator whole square, that means x square. I think you understand. Now again there is a simple concept to proceed. I want to rub this part firstly. Now there needs only simplification. Now if you see here, you will get 1 upon x square plus y square, 2 times x square plus y square, x plus y times dy dx is equal to 2 upon, if you take here LCM, you will get 2 by x square plus y square, and it will go in numerator finally, and here it will be x square, and this will be x times, here it will be also x square, this x square is also here, both terms cancel each other, and here you will get finally x dy dx minus y, because dx will be 1. I think you understand very well. Again, I will suggest you, if you see this term cancel each other, when it goes in this term, here it is in denominator, after going in RHS, from LHS, it will be going numerator. Numerator and denominator cancel each other because both terms is same. Finally you will get 2 to also same, cancel. Finally you will get x plus y dy dx is equal to x dy dx minus y. If you take dy, this term in LHS, you will get y minus x into dy dx is equal to, this term when go in RHS, it will be minus times x plus y. I think you understand. So that's why dy dx is equal to minus x plus y divided by y minus x. If you multiply numerator and denominator by minus 1 factor, in numerator you will get x plus y, and in denominator you will get x minus y. So this is your required answer of this question. You can check all these problems are very easy. Only need to take patience during solving and proceed simple manner as previous all problems. I think you understand very well. Again, take next question for you. Next question will be 23. 23, very interesting. X times root under 1 plus y into root under 1 plus x is equal to 0. Prove that here there is also some restriction, x is equal to minus 1 to 1, and prove that dy dx is equal to minus 1 upon 1 plus x square. You have to prove. Again, I will suggest you, how can you solve? Simply you have to differentiate on both sides and proceed. Right here, after differentiating on both sides, you will write here derivative of x times root under 1 plus y with respect to x plus derivative of y times root under 1 plus x with respect to x is equal to derivative of 0 with respect to 0. In that case, you can take root under 1 plus y out of the derivative term and differentiate x with respect to x. Again, take x out of it and differentiate root under 1 plus y with respect to which function? X is equal plus. Again, you have to do here same. take root under 1 plus x out of it, and you have to differentiate y with respect to x. Again, take out of derivative term y and differentiate root under 1 plus x with respect to x. Have you understood? And derivative of 0 will be 0. Now, as you know that this is root under 1 plus y, and derivative of x with respect to x will be 1. Now here, derivative of root under 1 plus y with respect to x you cannot find. So firstly you have to find derivative of root under 1 plus y with respect to 1 plus y. Again differentiate 1 plus y with respect to x. Now I want to write here, there is no space, it will be very long, that's why I want to do shortly here. X times, firstly, I want to firstly write here, you have to do as it. Differentiate firstly root under 1 plus y with respect to 1 plus y, again differentiate 1 plus y with respect to x. Derivative of root under 1 plus y, root under 1 plus y with respect to 1 plus y. Suppose that this is root p, looks as root under p, that means derivative of root under p with respect to p, just as 1 upon 2 root p, that means p, what is p? P is equal to 1 plus y. And derivative of 1 plus y, as you know that it is an addition form, derivative of 1 with respect to x will be 0, and derivative of y with respect to x, simply you have to write here dy dx. Have you understood? I want to run this part. Plus, now take here, this is similar manner root under 1 plus x dy dx, and this term will be y into. Now, as I have done derivative of this term, similarly we have to find derivative of root under 1 plus x, but here root under 1 plus y, that gives in second term dy dx, but there is given 1 plus x. Firstly, if you differentiate, you will get definitely root 2 1 upon 2 root under 1 plus x, but in second term when you differentiate 1 plus x with respect to x, it will be 1, because derivative of 1 will be 0 and derivative of x with respect to x will be 1. That's why it will be 0 finally. That means this is your third step for this question. Now I think you understand. Now see in this question only where present dy dx in third term in second term. So firstly take this term, write this term also in right. In that case you will get firstly take this dy dx, that means 1 upon 2 root under x plus, that means 1 plus y plus root under 1 plus x dy dx. I have taken common both from second and third terms dy dx. Then you will get in right hand side minus root under 1 plus y minus y upon 2 root under 1 plus x. I think you understand very well. So after taking LCM or calculation, you will get here dy dx is equal to, firstly you have to take here calculation. In that case you will get 2 times. First you take LCM 2 minus out of it. In that case you will get 2 times root under 1 plus x into root under 1 plus y minus y divided by minus y. Here I have taken already minus, that's why do not take here, simply take here plus, and take it in under bracket, and in denominator you will get 2 times root under 1 plus x. Again, when it goes in denominator, it will be 1 plus here 1 plus 2 into root under 1 plus x into root under 1 plus y. I think you understand very well. Now, and its denominator portion, it will go in numerator, because when this term comes in denominator, it will be numerator after taking LCM. So it will be in denominator root under 1 plus y, root under 1 plus y. Now, here you get as this term. Now you have to simplify. By which process? Now you have to simplify this by taking, or if you see in your question, it is also very easy, because here root under x into root under y plus, if you see here, this is what? This is root under 1 plus x. So you can put root under 1 plus x, and after simplification you will get your appropriate answer, that means required answer of this question. Now if I think this becomes very lengthy for you and calculation boring this question, so I want to give another method also for this question. This is also a good method, but it takes more time, that's why you can leave this method. And the second method is as simply you have to do, firstly this is equal to x into root under 1 plus y plus y into root under 1 plus x. I think you understand which is 0. Now you have to take this term right side. In that case you will get x times root under 1 plus y is equal to minus y times root under 1 plus x. Have you understood? Now you have to square on both sides. Squaring on both sides you will get simply x square into 1 plus y, and the right side you will get y square into 1 plus x. Now you have to simply differentiate, you will get your exact answer very easily. You can, now you have to differentiate. This is your second method. Now I think you understand very well this chapter, this question. Now I will give you a different kind problems, that means which is also relevant to same, that means implicit function question. See here, and I think this question is very interesting. Right here, derivative of, next topic will be derivative of some a special kind of function. Some a special kind of function, it is also called infinite expression. That means you have expression, that means you have to but this function is just as an implicit function. Now you have here find to derivative of that function with respect to x. First of all I want to take one or two questions, thereafter you will very easily understand. Here it says if y is equal to root under x plus root under x plus root under x plus dot 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 up to infinity, and you have to find dy dx. Very interesting question and very easy. Now you will tell me, sir, how can we differentiate? If you go through usual way, firstly differentiate root under this term with respect to this, again whole function differentiate with respect to this, means that it becomes totally boring for you and takes very long time, and its answer also mismatch when you will go usual way. That's why I will suggest you another methods to understand this concept. A easy quotes I want to tell you in Hindi. समुद्र में से अगर हम एक जग पानी निकाल लेंगे तो क्या समुद्र में कोई असर पड़ेगा? कोई असर नहीं पड़ेगा, फिर भी वो लगेगा उतना ही है, थोड़ा भी उस पे असर नहीं पड़ेगा, क्योंकि समुद्र में इतना ऑलरेडी पानी रहती है, इनफाइनाइट काफी ज्यादा मात्रा में रहती है, तो उसमें से एक जग पानी निकालने से क्या असर पड़ेगा? कुछ असर नहीं पड़ेगा। बस इतना अगर आप समझ गए तो क्वेश्चन समझिए आपका खत्म है। अब देखिए, कभी ऐसा होता है कि समुद्र में से एक जग पानी अगर निकाल लिए तो हम कहेंगे समुद्र का पानी घट गया? कभी नहीं होता। सो चलिए अब हम लोग चलते हैं क्वेश्चन में, कैसे बनाएंगे ऐसे क्वेश्चंस को। फर्स्ट ऑफ ऑल सी हियर y is equal to root under x plus root under x plus root under x plus up to infinity. I will suggest you an idea about it. See this question and by your intuition idea you have to identify after which terms similar terms repeated again and again, just as first terms x root x plus root x plus root x, that means this term is repeated many times. First of all, squaring on both sides, in that case y square is equal to 1 x plus, after squaring on both sides this radicals are removed, but inner terms all will be remains, that means here x is there and plus all these inner terms will be remains that means x plus root under x plus root under x plus root under x plus dot 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 up to infinity. Up to infinity. Up to infinity. Now, if you see this question, what is this? What is this? This is y. Why? Because I have already told you, when you take one jug water from sea, does not affect it. Both will be same. This is also y. Because it is also infinite times repeated, then it looks as same. So it will be also y. So you get y square is equal to x plus y. Now you have to simply differentiate on both sides. After differentiating on both sides, you will get derivative of y square with respect to x will be derivative of x plus y with respect to x. That implies the derivative of y square with respect to x. Firstly, write here derivative of y square with respect to x, which will be 2y, and derivative of y with respect to x is equal to, again differentiate derivative of x with respect to x will be 1 and derivative of y with respect to x. I think you understand very well. Now go ahead. This term take LHS, you will get 2y dy dx minus dy dx is equal to 1. After taking dy dx common from both terms, you will get 2y minus 1 dy dx is equal to 1. So dy dx is equal to what? 1 upon 2 minus 1. You just had खोदा पहाड़ निकला चूहा, वैसा वाला सवाल ही हो गया. क्योंकि देखिए completely questions looks very lengthy and up to infinite terms. I have, when I see this question, it looks very lengthy and more complicated, but when I solve, looks very, I think you understand very well. Again take next question for your similar kind question. This is equal to y is equal to root under sin x plus root under sin x plus root under sin x plus dot 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 up to which? Up to infinite terms. Up to infinite terms. Similar manner you have to again do. Squaring on both sides, you will get sin x plus root under. This radical sign will be removed, and here you will get sin x plus what? Sin x plus root under sin x plus root under sin x plus dot 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 up to infinity. That means y square is equal to what? Sin x plus what? Y. This is also again y. Now you have to differentiate on both sides. I want to write directly. After differentiating on both sides, you will get here 2y dy dx is equal to cos x plus dy dx. So after taking our common from first term and this term, do dy dx, you will get 2y minus 1. I have taken firstly LHS. After it, you will take a common dy dx from both terms. You will get 2y minus 1 times dy dx, which will be cos x. So finally, you will get dy dx is equal to cos x divided by 2y minus 1. This is your correct answer. Now, I want to take a next question for you. See here. (26) is a very interesting question. See here. Actually, this question is also asked in IIT. Sin y is equal to x times sin a plus y. Find, prove that dy dx is equal to sin square a plus y divided by sin a. Divided by sin a. In this question, you have to find dy dx is equal to sin square a plus y divided by sin a. How can you proceed? Actually, this question is asked in IIT. That's why I want to explain it very well. If you see this question, definitely you will try to go by differentiating on both sides with respect to x. When you go through differentiating on both sides with respect to x, it will be more complicated for you. Why? I want to tell you here. If you try to express x, if you find value of x in terms of y, it will be sin y upon sin a plus y. I think x is equal to this term. and after manipulation you will get definitely as it this answer. That's why I am telling you, do not differentiate on both sides with respect to x. Try to differentiate on both sides with respect to y. Now you will tell me, sir, now here I have to find dy dx, but why do you differentiate with respect to y? In that case I will get dx dy. Don't worry, because I want to tell you one important factor, dy dx is equal to 1 upon dx dy. That means if you are able to easily find dx dy, then using this formula, using this concept, you can find dy dx very easily. And now proceed. So I want to differentiate, but here be careful here, because sometimes students do mistakes. Differentiating on both sides with respect to y, properly write here, because or not you will confuse, because mostly students always differentiate on both sides with respect to x. That's why he definitely does any mistake as it differentiating on both sides with respect to y. In that case, you will get an analogous dx dy is equal to. Now you have to differentiate, because it is in quotient form. That's why you have to apply here derivatives of quotient rule of derivatives. That's why firstly you have to take sin a plus y out of it and differentiate sin y with respect to what y. Again minus, take out of derivative term sin y and differentiate sin a plus y with respect to y and divided by derivative divided by denominator of this term, that means sin square a plus y. I think you understand. Now here you have to do simple manipulation, right here, sin a plus y, so it will be sin a plus y. Derivative of sin y with respect to y will be cos y minus sin y. Derivative of sin a plus y with respect to y. You cannot find here directly. That's why firstly find sin derivative of sin a plus y with respect to a plus y. In that case, you will get cos a plus y. And you have to again differentiate a plus y with respect to y. In that case, you will get derivative of a will be 0 y, because a is a constant, and derivative of y with respect to y will be what? 1. And if you take as a multiplication of y, with this term 1, it is unaffected. So in the numerator you will get completely sin square a plus y. Now if you see, you will definitely write something mixed here. Now if you see each denominator, suppose this is a, this is b. In that case, it looks as sin a into cos b plus cos a into sin b. So completely it will be sin a minus b. In place of a, there is a plus y. B, that means what? Y divided by sin square a plus y. Here y minus y cancel each other. Finally you will get dy dx. So you will get dy dx is equal to sin a divided by sin square a plus y. Sin square a plus y. And you have to find dx dy. Sorry, dy dx. So dy dx is equal to 1 upon dx dy. As you know that 1 upon dx dy is equal to sin a by sin square a plus y. So sin a by sin square a plus y. So it will go in numerator. So it will be finally sin square a plus y divided by sin. This is your required answer of this question. In general, a student firstly differentiate on both sides with respect to x. Definitely it will feel trouble during solving if he tries to differentiate on both sides with respect to x, but definitely by that method also solved very easily. Now next topic will be for you derivative of parametric function. And I think in next class I will discuss about it, because in this class I have discussed about two methods. That means different kinds of problems. Firstly, implicit function and extended form of implicit function. I think you understand very well this class also. And now you have to solve corresponding problems related chapters. And in next class I will discuss about what do you mean by parametric function and how can you differentiate parametric function related problems. And I will suggest you for remembering point of view, such that in examination without short-term revision you can attempt, that means you can secure good marks. I want to give you some hint. First of all, if you see here, there are many chapters. In your examination, before examination, in one day, because there are many topics, you cannot recover one day all topics quickly. That's why I will suggest you, there are separate chapters. That's why take a page and separately write 8A, 8B, and from each topic take one question, and you will take that question which will be, that means having some standard, that will be very standard problem, take and solve by usual way. Definitely when you before going examination, when you will see only that problem, your all forgotten concept recovered that time totally. That's why you will do that as I told you. Okay, thanks. In next class I will again meet you. Bye.